Hi everyone. Thanks for joining us and hearing this presentation. This is Centroid's presentation based on smart city solutions for managing air quality. I'm going to introduce the topic really quickly as well as introduce Centroid, so who we are and what we do, as well as some of our key personnel. And then Dr. Ardavan Bakhtari will take over for the bulk of the presentation, where he will briefly mention the urban air quality monitoring limitation, and then immediately after follow through with the urban air quality monitoring solution. At the very end, if there is any questions, please send an email to any of our representatives, and we are more than happy to answer them. Dr. Ardavan Bakhtari is the founder and president of Centroid. Dr. Bakhtari has a PhD from the University of Toronto, where his research focused on combining sensing technologies with artificial intelligence. Dr. Bakhtari is a specialist in instrumentation with an extensive background in the environmental, nuclear, and medical industries. He has been involved in numerous international projects, which focused on industrial air and odor monitoring, as well as mitigation. Anton Jitnikovich, that's me. I am an air quality specialist at Centroid. I have a Master's of Science degree from Wilfrid Laurier University, which focused on the calibration and application of high-resolution sensor instrumentation. I have over 5 years of experience working alongside various government, corporate, and academic institutions in the environmental field, and my geographic area of focus is in North America and the Middle East. A little bit about Centroid. We are a world leader in air sensory technology. We provide intelligent environmental solutions across a wide range of industries. We manufacture a wide range of instruments that are related to air quality and odor monitoring. All of that is done in-house. We are proudly Canadian. And we also provide environmental services such as odor controls, emission monitoring, air dispersion modeling, as well as remediation and mitigation recommendations in order to fulfill environmental compliance actions. Centroid has a global reach where we manufacture all of our products in-house in Canada, and we export them to over 40 countries worldwide. And that map on the right-hand side of the screen, that map represents the countries that we have currently done business in. And with the exception of Antarctica, we have currently been involved in every single continent on Earth. Through innovation and unwavering focus on our clients' needs, we customize our solutions to the unique scope of each country or territory. Here's an overview of some of the larger projects and larger industries, corporations, and institutions that we've worked with. They range quite a bit, and I won't get too much into detail, but I will state they range from governmental agencies, environmental laboratories, research institutions, as well as small, medium, and large-scale corporations. As for the urban scanner, which is now the bulk of this, I will let Dr. Ardavan Bakhtari discuss the main points of this project.
This is Dr. Ardavan Bakhtari, and I'll take over for explaining what the project is that we have, the product that we are offering, and some of the key issues that it solves within the urban air quality monitoring. Now, getting street level air quality data is quite challenging, and the main problem is, so the air quality is alarmingly high. Even here in Canada, we find quite high amount of pollution in downtown core, and the variance between two streets is really large. Depending on the time of day and where you are, you will see many folds of increase in the air quality. Now, what the issue that we're trying to focus on is trying to map out what these variations in spatial and in time are within the city. So when you look at the challenges that we are facing, this is a map of Toronto. It's around 150 kilometers wide and let's say about 100 kilometers in height. It's quite a big city to cover with fixed air quality monitoring. Now, if you put, let's say, in Toronto, 10, 20, even 50 air quality stations, you quickly see that the grid is quite big and you can't really get a street by street level monitoring. So what is the solution? Now, some of the solutions that people have tried to do is they have tried to come up with arithmetic models, some kind of way to determine between 2 points what's going to be the air quality. This is going to be quite challenging because there's so many different metrics that play into it, and it's difficult to get that model to work perfectly. So what is the proposing? Now the solution is to look at it a different way. Instead of having fixed monitoring station, we want to have mobile monitoring station, and as it moves, it collects data. And we're going to have completely independent of the location of the monitoring station. So you actually get data from each and every street. Now, to do this, we have what you see on the right. So it's a vehicle, and on top of it is an air quality station. And it's quite a compact air quality station. It does a lot more, which I'll go into it. Some of the main things is that it measures pollutants in real time, and that's 1 sample per second, so quite a fast sampling rate. It stores the samples on the device itself, so it's quite secure. Plus, it sends it to the cloud server, so you have that redundancy, so you don't lose samples. One of the main things is that it does a self-calibration. So as you drive, it will check its zeros continuously to make sure that the sensors are working properly. It will create a map of the city streets and their corresponding air quality. We incorporate quite a sophisticated algorithm which kind of uses the data that we collect through this instrument to determine a very complex spatial and temporal model that will take into account spatial and temporal changes of air quality. We create this model based on a number of different sensors beside air quality sensors. So I'm going to get into those now as well. So the sensors that we are using, first we have the air quality sensors. So we use quite high resolution sensors. Those are going to be ppb level sensors for measuring everything from CO, CO2, NO2, ozone, all the main pollutants, to some perhaps industry specific pollutants like H2S or something else, depending on the industries that are in the city itself. We also use LiDAR, so that's a laser instrument that will measure the distance from the equipment to each point within the street and basically create a 3D map of the entire city. And this is a very accurate 3D map. Within a few millimeters, the entire city is mapped out. We also have a 360 camera, which we use for a number of things, such as traffic count, such as determining the type of cars that are on the street, the kind of industry, the kind of topography we're dealing with. And we also have an ultrasonic anemometer, and this is used to determine the exact wind speed and wind direction, even as we drive. So we can collect wind speed of not just the apparent wind, but the actual wind, even when the vehicle is moving at 100 kilometers an hour. Then we have a very sophisticated post-processing that combines all these to create a model of the city. And this is basically the end product that we're trying to get to. So the instrument, as it drives, it will collect the pollutant and particulate matter concentrations. It will collect temperature, it will collect humidity, barometric pressure, GPS position. It will record the sampling time. This is GPS time as well to the millisecond. It will collect LiDAR data. That's a 3D map of the city. It will collect a continuous 360 image, quite high definition image of the entire city. Wind speed, wind direction. We have the option to put thermal imaging, and this is to kind of determine hotspots such as industries or stacks, things that may not be so easily visible on a 360 camera. I'll go over some of the technologies here that we're using. So here is a picture of the LiDAR. It has quite a quick sweep rate. So 10 hertz a second, it will spin. You can actually put that even higher. It will collect about 1,000 samples per second. And the range is actually, here we say up to 12 meters, but the new model even goes further than that. I think it's up to 50 meters. Verify that. The resolution is really good. It's going to be within centimeters or even millimeters in this case. And each sample will be an angle and a distance. And there is a software that will put that all together and give you a live 3D view of the entire city. Here's a picture of the 360 camera. So it will, at the bottom, you'll see an actual image taken with this camera. So you'll see the entire surroundings of the vehicle. So you can do traffic count from the front. You can see what the building height is from the side. So you really get a lot of information through this instrument as well. And the ultrasonic anemometer gives you really accurate wind speed, wind direction. There's no moving parts. So it's quite reliable. And based on using the GPS data, we get the speed and direction of the vehicle. And then based on that, we calculate the actual wind, even when this vehicle is moving. So whatever we read from the anemometer, we can calculate the real wind as if we were standing still. So what happens with all these data? They get stored on the server that's local, plus they are sent to our cloud server. And some of the data is processed live, such as the concentrations and wind speed, wind direction, and some of the data that need bigger processing are processed offline on our cloud server, such as LiDAR and images. Here's what you see as you drive. So you'll see quite a lot of data. So usually we have two people driving. One is the driver and the other one is just looking at the data. And as you see at the top left, you'll see the LiDAR, and they can see the actual city in 3D. On the right-hand side, you'll see a map with air quality points. So the color of that point represents how bad the air quality is. Very similar to the normal air quality standard. So red meaning the worst and green being good. Now, looking down on the second row, you see wind direction, wind speed, and you get these kind of wind rows to show you where the wind is most coming from, most often. And on the right hand of it, you'll get the concentrations. This is a time-based series graph, but there's a lot of graphs that are generated in the cloud station, in the cloud software, that will show you how the pollution changes based on time as well as space. And on the bottom, you'll see the picture of what you're collecting. Here's an actual picture of basically we use a computer that's like a 2-in-1 tablet computer. And as they are driving, the passenger is looking at all that information live and seeing, if you see a big spikes of certain pollutants, you can change your route, you can stay in certain areas. So it really helps to be able to continuously collect and see the live data. Now, the main objective is once you collect all this data, we can create a live air quality. So this is what it's going to look like, right? And you see the hotspots, and this model changes based on time of day, based on traffic count, based on quite a few things. So what you give to the model, you give it GPS coordinates, you give it date and time, and it will give you what the air quality value is. And this is what you really want from the model. But it will take a lot of things into consideration, such as the height of the buildings, the weather, the industries, the type of industries that are, the type of topography that is around each location. So it takes all those in, but all it will give you is the air quality data, like what is NO2 in ppb values in this location at this time. But we want to have a way to continuously update this model, because maybe traffic changes, maybe streets change, new buildings come up, new industries come up. So what we want to have is a way to update our model. But we don't need to have the entire urban scanner redo the model and collect all those heavy data. So what happens is in the third phase, let's say the first phase was to collect the urban scanner data, the second phase was to run the live model. In the third phase, what you have is you have smaller stations. You'll see a picture on the top right-hand corner, and you'll see a small box on top of this police car. It's collecting air quality data. So it's not LiDAR, it's not camera, nothing of that, just air quality data plus temperature and humidity. So it will collect that data and it will feed it back into the model for the model to self-learn what has changed since it was last created. So it's sort of like a continuously update, which nobody needs to interfere with. It will by itself continuously update. So you can put 20, 30, 50, whatever number of stations, and mount them to streetcars, to buses, to police stations, to Uber cars, and the options are quite endless. And as these cars move about doing their normal business of covering the entire city, you will get this data back and use that to keep updating your model. So you're always looking at the latest air quality, street by street, minute by minute for the whole city. Thank you so much. So that's a brief summary of the product that we are offering and the capabilities it has. Now, as